Hello everybody, welcome to linuxin.com YouTube channel once again. Today we are going to talk about an OpenCV course. Okay, so this is the course outline that we have right here, and these are the 17 most important topics that we have chosen for you. Okay, so we're going to discuss one topic one by one, and probably we're going to do code examples, all right, for all of them. So the idea is that if you talk about OpenCV, the first topic is introduction. It is very important. So the question is that what is OpenCV? So OpenCV, which also stands for Open Source Computer Vision, it is a library of programming functions mainly aimed at real-time computer vision. In simple language, it is a library that is used for image processing. It is mainly used to do all the operations related to the images. All right, so the histogram, the detection of the faces that you see on Facebook. If you upload a picture, they actually recommend you that do you want to tag a specific person. How do they do that? They do that with facial and image recognition technology that they have, and obviously they have that because of this OpenCV. That is the same logic that is being used right there. Okay, so then the question arises that what is a computer vision? So the idea is that computer vision is a field of computer science that works on enabling computers to see, identify, and process images in the same way that human vision does, and then provide appropriate output. So the idea is that the computers, if they would look at the image, they won't look at those images in the same way as we humans do. All right, so the way of computer actually looking at those images is quite different than us, and processing is obviously different as well. So it's like imparting human intelligence and instincts to a computer. In reality though, it is a difficult task to enable computers to recognize images of different objects. So a little combination of AI is being used here in computer vision. All right, so now we're talking about OpenCV, that what it can do. It can read and write images, and we've got examples of that. It could detect the faces and its features. We also have eye detection and face detection example in this course. Then number third is that detection of shapes like circle, rectangle, etc. in an image. We also have an example regarding this. Then text recognition in images, e.g. reading number plates, etc. Okay, you can do that. We don't have any example regarding this, but we would have in another course that would basically post regarding OpenCV. Okay, that would be a detailed course. This is kind of a mini course that we're creating right now. We'd also create a detailed course in which we'd try to cover everything regarding OpenCV, that is. Okay, so number 5th, we have modifying image quality and colors. Instagram cam scanner. These are the examples. So on number 6, we have developing augmented reality apps. So that is not it. It can do a lot more other things that we have not mentioned here. So these are just, we are barely scratching the surface here. There are a lot of other things that you can do with OpenCV, and we'll see that in detail. Let's talk about the history of OpenCV. So it was officially launched in 1999. OpenCV project, it was initially an Intel research initiative to advance CPU intensive applications, part of a series of projects including real-time ray tracing and 3D display walls. All right, so we also have examples regarding line tracing in the road and things like that. Okay, so the main contributors to the project included a number of optimization experts in Intel Russia, as well as Intel's performance library team. In the early days of OpenCV, the goal of the project was described as, number 1, as advancing the vision research by providing not only open but also optimized code for basic vision infrastructure. The other one was like dissemination vision knowledge by providing a common infrastructure that developers can build on. And another point was that advanced vision-based commercial applications by making it portable. Okay, so the alpha version, the first version of OpenCV, was released to the public at the IEEE conference, which was on computer vision and pattern recognition. There's a lot of research that is being done on OpenCV, and a lot of scholars and researchers are doing the work on it. And you can find all their work by going to IEEE website or Springer or journals like. And then you can basically download some of the papers and then you can read them in order to get an idea about the research which is being done on OpenCV. All right. So that was the introduction to OpenCV. So now let's go ahead and let's discuss the installation of OpenCV on your Ubuntu machine. So in order to install OpenCV, all you have to do is you have to press Ctrl-Alt-T and you have to open up the terminal, okay? So when you open up your terminal, we could zoom in a little bit. And the idea is that you can install Python on your system first, because the Python, OpenCV, we are going to work with Python, okay? So you have to have Python installed on your system. Ubuntu, it comes with Python pre-installed. So all you have to do is you have to write here Python 3 and then -- version. Okay, so at the time of the making of this video, Python 3.7.3 is the latest version of Python 3 which is installed on your system. So in case if Python is not installed on your system, what you can do is that you can write here this simple command sudo apt install, and then you can write here Python 3. Okay, I already have it installed, so when I would hit enter and I would put in my password, it won't take that much long and it would tell me that your Python version 3.7.3 is already installed. Okay, so once you have Python installed, now in order to install OpenCV, all you have to do is you have to write here sudo apt install, then you write here Python 3, and then you write here hyphen, and then you write here OpenCV. Okay, so once you have written this command, you hit enter, and here you can see that it is asking for your permission. Do you want to continue? So press Y, and it would take 475 megabytes of additional disk space on our computer. Okay, so now it is downloading, and after downloading it, it would basically install OpenCV on our Ubuntu. So in order to install OpenCV, all you have to do is you have to press Ctrl-Alt-T and you have to open up the terminal. Okay, so when you open up your terminal, we could zoom in a little bit, and the idea is that you can install Python on your system first, because the Python, OpenCV, we are going to work with Python. Okay, so you have to have Python installed on your system. Ubuntu, it comes with Python pre-installed. So all you have to do is you have to write here Python 3 and then -- version. Okay, so at the time of the making of this video, Python 3.7.3 is the latest version of Python 3 which is installed on your system. So in case if Python is not installed on your system, what you can do is that you can write here this simple command sudo apt install, and then you can write here Python 3. Okay, I already have it installed, so when I would hit enter and I would put in my password, it won't take that much long and it would tell me that your Python version 3.7.3 is already installed. Okay, so once you have Python installed, now in order to install OpenCV, all you have to do is you have to write here sudo apt install, then you write here Python 3, and then you write here hyphen, and then you write here OpenCV. Okay, so once you have written this command, you hit enter, and here you can see that it is asking for your permission. Do you want to continue? So press Y, and it would take 475 megabytes of additional disk space on our computer. Okay, so now it is downloading, and after downloading it, it would basically install OpenCV on our Ubuntu. Okay, so once you have done it, now you can see that OpenCV is installed. But how do you know that OpenCV is installed on your system or not? One thing that I want to tell you, that make sure that before you write this command, like sudo apt install python 3 -opencv, make sure that you update your repository by using a command sudo apt get update. Okay, that is fairly important. So something like this, sudo apt get update. Alright, it would update your repositories, and then you can simply use this command to install OpenCV. Alright, so I'll just clear it right now. And how do I know that if Python OpenCV is installed or not? So for that, you would just write here Python 3, hit enter, and now you have an interpreter here where you can write code basically. So now you'll write here import not open, actually you write here cv2, and once you have done that, after that you just simply write here print, and here we would write here cv2 dot and then hyphen underscore version, then again underscore, you hit enter, and you can see that the OpenCV's versions that is installed on our system is 3.2.0. But the thing is that it is not the latest version of OpenCV. So how do I know that? If I go to the website of OpenCV, which is essentially opencv.org, here we have the OpenCV version, which is essentially OpenCV 4.1.2. Alright, so that's what we want to install. We don't want that previous version, right? So if you don't want that previous version, and if you want to install a newer version, all you have to do is that you have to install pip modules first. Once you install them, then you can basically go ahead and you can install the latest version of OpenCV. So in order to install pip, all you have to do is, first of all, you need to update the repository. You write here sudo apt get update. Alright, so you update your repository. Once you have updated your repository, then you write a simple command that would essentially install the pip module. Okay, so now after updating my repository, what I'm gonna do is that I'm gonna write here sudo, then I'm gonna write here apt, then I'm gonna write here install python 3 and then hyphen and then pip. Okay, so this would install pip module on our Ubuntu system. So I would hit enter, and you can see that it is asking me do you want to continue. So I press Y, which means that it would start to download the pip module, which would essentially cost us 93.5 megabytes of additional disk space on our computer system. And once it downloads it, it will basically extract it, and then it would install this on our Ubuntu computer system. And once it is done, we can move ahead and we can install the latest version of OpenCV of Python on our Ubuntu system. So we'll wait. Okay, so now what we're gonna do is that we're gonna write here pip install OpenCV -Python. Alright, so when we hit enter, now it would basically go ahead and it would try to install the latest version of OpenCV, and the latest version of OpenCV is essentially 4.1.2, right? Previously, when we used solely the Ubuntu repository, it installed a previous version of OpenCV, which was essentially 3.2 point something, right? So once it is installed, after that we'd run the same thing. We'd go to Python 3 interpreter, and there we can import CV2, and then we can print out the CV2 version to know if that is the latest one. Okay, so we will wait until it downloads it, extract it, and then install it. Okay, so now you can see that it says successfully installed OpenCV Python 4.1.2, right? And here if you take a look, that is 4.1.2. But still, if you want to verify, how do you do that? So now you go to the Python interpreter, and here you write here import CV2, and after that you write here print, and then inside of here you simply write CV2, then you write here dot underscore version, then double underscore, you hit enter, and there you go. You can see that we have a 4.1.2 version of OpenCV successfully installed on our computer system. Okay. Okay, so next topic is display video using camera. So often we have to capture live stream with camera. All right. OpenCV provides a very simple interface to this. So in this example, we're going to capture a video from our camera, which is essentially webcam, and every laptop has it. And we are going to basically convert it. First of all, we're going to capture it in a color way, okay, the colorful video image. And then we're going to basically convert it into black and white or grayscale video. Okay, so in order to capture a video, obviously we're going to write that in a Python script. And the thing for you to know is that you can write Python code in Python IDEs like, you know, Spider maybe. So a lot of people like those IDEs because they give you that feature which autofills these built-in methods for Python. But I really like the simple text editor that we have on Ubuntu. And that's what we're going to use. But if you want to use any of the IDEs, you can actually use them as well. All right. So what I'm going to do is that I'm going to open this hello.py file. All right. So this is a Python script. All right. We know that. So first of all, what you have to do is that you have to import CV2 right here. And in order to run Python script, what you need is that you need to have your terminal. Okay, so in the terminal you would write the Python and then you not the Python, but actually you would write here the name Python and then space and then the script name, okay, whatever the Python script name is. In our case, it is essentially hello.py, so we're going to use that. And make sure that when you're running that Python script, you're in the same folder where the script resides, okay? So I'll show you in a while. So first of all, we have to import CV2, and then we are going to create a capture object, you can say. So let's call it cam, and then we're going to write here CV2. And after that, we're gonna write here the method that we were talking about, and that is essentially video capture. Okay, so the idea is that in here I could pass like 0, or if you know, 0 basically represents the default webcam, and in case if 0 doesn't work, you can always put here -1. That is the same in case you have multiple cameras attached to your device. In that case, you're going to move one step forward. So for example, if you have 2 cameras, for first one, you're going to have 0. And for the second one, you're going to have 1. So let's say if you have 3 cameras, in order to access the first one, you're going to write here 0. For the second one, you're going to write here 1. And for the third one, you're going to write here 2. Okay. But we really want to focus on our default camera, which is essentially our webcam. And in order to access that, we just need to write here 0. Okay. So after that, we come down here, we write here a while loop which would stay true, and then we're going to have here call. So this while loop is staying true until unless we press a key to quit the video showing or video streaming, or we can basically go ahead and, you know, from the terminal we press Ctrl-Z or Ctrl-C or something like that to interrupt the program. Okay, so these are the 2 ways. So let's say that what we are going to do is that we're going to write here while true, and here we are going to capture frame by frame. Okay, so in order to do that, you just write here frame, which is essentially a variable, and then we basically write here cam.read, okay, which is a capture object. And cam.read, basically it returns a Boolean value. Either it is going to be true or it is going to be false. So if we have read the frame correctly, it will be true, and you can check the end of the video by checking the return value. Okay, so obviously once you have captured the frame, and obviously it is a return, it is a true or false value, so we're going to have here a return. And then obviously the image that we're going to show, or the video that we're going to show, is it's going to be colored. So we want to show it, and for that we'd use a built-in function available in Python CV, which is ImShow. And in here inside these brackets we're going to pass two arguments. One is going to be frame and the other one is going to be the variable frame. Okay, so now this is sort of displaying the result frame, and then after that we want to have an if condition here, and we want to have that if condition in order to break out of this while loop. Okay, so if the while loop is going to be true, it's going to run. So once we have done that, now what we're going to do is that we're going to have here an if condition, and that if condition we're going to have here because we want the camera to run until and unless a specific condition occurs, and that's going to be specifically that when the user hits a key from our keyboard. Okay, so let's say here we have an if condition, and we're going to write here cv2 dot wait key, and that is gonna be essentially 1. Okay, and then after that, and then we're gonna have here an AND condition, and here we're gonna write the hardware number 0xFF, which is a hexacode, and then we're gonna write here a double equal sign. We write here ORD in order to shut the program. Okay, so what we're gonna do is that we're gonna write here the key that we want to use. So let's say I want to use K here. All right, so after that what we're gonna do is that we're gonna write here a break statement which would actually break us outside the while loop. Okay, so when you're done with everything, make sure that you basically release the capture object which contains all the resources. So for that, you're just going to write here cam, which is essentially our capture object, and then you're going to write here the method, which is essentially release. All right, so once you do that, the last thing that you want to do is the window, right? The video capturing would open up in some sort of window, and we want to destroy all the windows that are there. So for that, what we would do would just write here cv2, and then we'd write here dot destroy all windows. All right, so this is another method, and we are done. And one more thing that you want to make sure is that you put this colon here, because this is the syntax and it's gonna give you an error if you don't have it right here. So I press Ctrl S, I come here, I'm gonna run here the script which I would run essentially by writing here Python, and then I'd write here hello.py. I hit enter, and now it would basically run my webcam, and now you can see that I'm showing a book here which I have, right? So this is basically streamlining my video. So now if I try to cross it right here, you can see that it can't happen, right? So what I can do is that I can press here any key on my screen, but it won't work until I press K. Okay, so I would just press K, and now you can see that it's gone. And why it is gone? Because I have pressed K right. So that was basically a colorful video framing, and now if you want to make it a grayscale, you can also do that. All you have to do is that you have to add one line to make it black and white, because recently it was colored, right? A rework book that I have shown you. So now that was in color, okay, and now I'm going to show you that in black and white. Okay, so what you need to do is that just right here, just above here, you need to write here a variable which could be black and white, okay, BW, and in here all you have to do is that you have to write here cv2 dot, then you write here cvt color, and then you write here brackets, and in here you pass the variable first, which is essentially frame, where we are capturing it frame by frame. And after that what you can do is that you can come here and you can write here cv2 dot color, cv2 dot color, which would be all in capital, and then underscore, and then you will have here bgr2, then you would have here gray. Okay, so once you have done that, the other thing that you need to do is that you need to change the passing variable here, which is essentially the second argument, and that is going to be equal to bw, black and white. Okay, so once we are done here, that's all we need to do. Now let's go ahead, save this, and go to the same terminal and try to run that, and let's see if now our image is black and white. So now if we run this script like python hello.py, and now you can see that instead of being colored, this is now in black and white. So now in order to quit that, I'm gonna press K, and you can see bingo, the program is closed. So that's how you basically display a video using your webcam. Okay, so now let's move on to the next topic, which is essentially read and write images. So there we have read and write images. So now what we're gonna do is that we're gonna go to our script, and on my desktop, if you see, I have this image that I can read actually. So if I go to my desktop here, this is a small cat JPG image that we have, and what we're gonna do is that we're gonna write a script using OpenCV, and we're gonna read it. Okay, so first of all, what I'm gonna do is that I'm just gonna remove all of that. All right, and now I'm going to create a function in Python. Okay, so the idea is that if you don't know the basics of Python, you might not be able to understand this. So what I'm gonna do is that I'm gonna put the link in the description to our full Python course that you can take and understand Python, and then you can come back to this video, and after that you might start understanding all of that. So I'm not gonna get into the explanation of a function or what function is or what it can do. Alright, so I have already done that for you in another course, so you can go ahead and you can watch that. So now we're gonna have here a variable, and obviously we are in the same folder, right? So in our desktop we have the file, so we don't really need to write here the long path of the file. The name of the file would be sufficient. Okay, so after you write here the name of the file, now what you want to do is that you want to read this file. Okay, so what you're going to do is that you're going to have a variable here named as image, and then you're going to write here cv2, then you're going to write here dot, and you're going to write here im read, and inside here you're going to basically pass the path, okay, which is essentially cat.jpg, because our script resides on our desktop, and that's where our image is. So in case if image would have been somewhere else, then you would have to have here the complete path. Okay, I hope you have understanding of the path, right? So now what you're gonna do is there are 3 modes of reading. Okay, so what you can do is that you can either read the image in default mode, which is essentially by writing here 1 and -1. Okay, they both are the same. The difference is that there is a third mode, which is essentially 0, and it means a grayscale image, or black and white, you can say. Okay, so the idea is that when you do not have anything right here, so for example, if you write something like this, it would automatically assume it as 1, okay, as a colored image. But in case you want to specify that, you can also do that. It won't make any difference. But in case you want a grayscale image, for that you have to specifically write here 0. All right. So now we come to the next line, and if we don't write here 1 or -1, it doesn't make any difference. It would still be the same. So now if we want to show this, what we can do is that we can write here cv2.imShow, and remember that we are trying to read the image first, okay? Then we'd basically write it or save it. So we have this, and then in here we're gonna have 2 arguments. One is going to be the name of the window, the other is going to be the variable. So the name could be like anything, like image window, or we can call it like cat, okay, or cat image. Alright, so after comma you can have here the variable name, which is essentially img, and that is this variable name where we are basically reading it. Okay, so after reading it, we'd show it, and once we show that, what we're gonna do is that we're gonna write here cv2 dot wait key, and we can write here 0, and then essentially after that we want to destroy all the windows, or we can specifically destroy this window, and we can specify that we want to destroy this single window. We are going to have one single window anyway, so we just write here the name of the window, which is essentially cat img. Okay, so now we are done. So we have this method. So now this method or this function won't work by itself, so we have to call it. So for that we just write here if name, and then we write here double equals, and then we write here something like this, main actually, and then we write here colon, and then after that we basically call the function or the. And one more thing that we're going to do is that we're going to have double hyphen or double underscore, excuse me, here as well. And now if we save it, we go back to our terminal, we try to run our script. Here you can see that we have a window, and this is the cat image that we see right here. Okay, so I'm going to close it. So when we close it, now you can see that here if we write 1, we would still get the same result. Okay, and if we write here -1 and we save it, we go back here, we try to run our script again, you can see that still we have got the same result. But if we want to get the grayscale, all we have to do is we have to write here 0. If we save it now, we go ahead, we run our script, you can see that now the colors, they are gone. Okay, and you can see that the window name is cat img, which is essentially right here we have mentioned. Okay, cat img. All right, so now we have seen that how we can read an image, and now we are going to see that how we can actually write an image. Okay, so once we have read an image, we can write it as well with a different name, in a different directory, or in the same directory as well. It really doesn't matter. So what I'm going to do is that I'm going to read this image, and I'm going to write this image in the same directory. Okay, so once I've read it, all I can do is that I can have the output image, or output is a variable, and in here I want to save it by the name of, or I want to write it by the name of something else, like let's say cute cat.jpg. Okay, so now if I go here, I have imshow, but after that what I want to do is that I want to write here cv2 dot imWrite, okay, which is a function that is essentially being used for it is used for usually writing an image. Okay, so now we are writing an image, and as the first argument we're going to have the variable name, which is essentially output, okay, which holds the name of the file in which we're going to write, and then the image from where you want to write. Obviously, first of all, we have read the image inside the img variable, and this is the image that we want to write in as the output. Okay, so once you have done that, it's all you need to do, and now you save it. And right now, if I am able to show you that we don't have any cutecat.jpg on our desktop. Okay, so now we are going to write this image on our desktop. It could be in another directory as well, it really doesn't matter. So if we run this, you can see that we have this output here because of this, you know, 0 mode. But if we quit our program, right, and we go and we do ls here, you can see that we have cutecat.jpg which is written on our desktop. Okay, so we can write this on in another directory as well. All you have to do is that you have to take the path of that directory and you have to paste it right here. Okay, all that path along with the name of the file, and the same goes for the input as well. So that's how you basically read and write images in OpenCV. Alright, so now let's move on to our next topic, which is essentially saving webcam videos to files. So do you remember creating those, having that live stream of the webcam? We're gonna use the same thing but in a different way, and we're gonna write the videos and we're gonna basically save them. Okay, so what we're gonna do is that we're gonna go to our code here, and we are just going to remove all of that. Alright, and in here we're gonna have the same thing. We're gonna write here cam equals cv2, and then we write here dot video capture, cv2 dot video capture, and in here we're gonna, so now what I'm gonna do is that after that I'm gonna have another variable in which I am going to define a format. Okay, so there is a library for OpenCV, which is essentially for CC, in which you have different formats like XVID and stuff like that. So for that you can basically search on the internet as for CC, and on their website you can actually go ahead and you can take a look at how many of the formats are available there. Okay, so what you can do is that you can have here for CC as the variable name, and in here you can write here cv2, then you can write here dot. So here you're going to write here cv2 dot video writer underscore, which is a method basically, writer underscore for CC, and inside here you're gonna write here the format. Okay, so how do you write that? You write here static, and then you write here XVID. Okay, so this is the format for .avi, and obviously if the output video that we're gonna save, that is going to be with a .avi extension. So for that we just write here output, okay, which is essentially a variable name, and then we can have here cv2 dot video writer. Okay, and then inside of that we pass different arguments. The first of one is gonna be the file name, which could be anything, so we have it here video.avi. so this is gonna be the video that we would record, and then as the second argument we're gonna pass here the variable, which is essentially for CCC that we have declared just right above, and after that we're gonna have here 20.0, and then we're gonna have here comma, and here we're gonna have its resolution, that would be 640 and then comma 480. Okay, so this 20.0 is basically frames per second. And now what we're gonna do is that we are going to have a while loop, and in that while loop we're gonna recently, if you remember that we have used true here, so in this case what we're gonna do is that we're gonna have here cam dot is opened, which is a built-in method which would make sure unless the capture object is opened or the camera is open, it would do certain things that I would define below that, right? So here what I'm gonna do is that I'm gonna write here the same thing as I had written previously. I would just write here frame, I would write here an equal sign, and then I would basically read it, okay, in the similar way as I have done previously. And now the one essential thing that I'm gonna do is that I am going to write here output, which is essentially a variable name, and then I'm gonna write here write, and obviously this variable contains the video writer. Okay, so we are going to write the video using this. Okay, So once we have done that, inside we are gonna pass the frame variable, okay, and then we are going to have a gray, you can have a colored video or you can have a grayscale video, it really doesn't matter. So let's write here the same thing, BW, which was essentially black and white. Then we can have here cv2.cvt color, okay, and then you have brackets, here you have frame, you have a comma here, and then you can have here cv2 dot color, then you can have here underscore, and then you can have here bgr, and then you can have here 2, then you can have here gray. Okay, so once you do that, after that what you're going to do is that you're going to use the IamShow function. You write here cv2.IamShow, and in here basically you're gonna name the frame. Let's name it frame as well. We'll put a comma here, we write here BW. Alright, so once we are done here, we also need an if condition here. Okay, so the if condition is gonna be something like that. So we write here if we have cv2 dot wait key, okay, 1, and after that we have and here, and here we have that code 0xff. This is a machine code. We write here double equals, and then we write here the key k. Let's say whenever I press k, I want the while loop to be broken, so I would just write here break. All right, so once we have done that, we don't have to put here a semicolon because in Python you don't need to. And after that, what we're gonna do is, in the end, once we are done with the while loop, we want to release all the resources, and in order to do that, we just write here cam dot release, which is a capture object. Okay, and one thing here you need to do additionally is that you also want to release the output as well, because we want to release it because the video would be saved, right? So it means that the video has ended. All right, so we write that here, and then obviously we write here cv2.destroy all windows, or we can specify the one window as well, okay, with the name. And after indentation, you need to make sure that you have a colon here as well. Okay, so now if we save it, we go back to our terminal and we are going to try to run our script. And when we would run our script, it would start recording. So when we hit enter, you can see here we have our book. And let me just roll it something like this. And I roll it like this. And now the video has been made and it is recording. So what I do, I press K and I quit this. So once I have quit this, now if I ls right now, you can see I have video.avi. There is a file on my desktop which is the exact recording of the video that we have done right here. So now if we go to our desktop, we'd find a video.avi file right here. And I'm gonna open it up with VLC media player, and if I open it up right here, you can see that this is the exact same video that I have recorded, and I have, I was moving the book, and this is the recording and it's done. So I hope you have got the point, that's how you basically record a video and you save. Okay, so the next topic is timestamp on videos, or you can say the current time that you would show on videos. All right, so what we're gonna do is that we're gonna go here. In this code, we need to make a few changes. So the first thing, additional thing you can say that I'm gonna do here is that I'm going to import a library which we can call as datetime. Alright, so this is a datetime library, and the thing is that inside the main function we have to have this video capture. That is absolutely fine, We don't need this like 4cc and output thing because that was related to the video anyway. We need this while loop, we need this frame variable, and obviously we don't need this thing right here. Now what we have to do is that we have to have an if condition here, which would basically do nothing, but it would make sure that we are doing everything only if the if condition is true. So what we're going to do is that we're going to write here if return double equals true. Then in that case, what I want to do, let me just basically delete this thing here as well because we don't need it anyway. We need IAMShow function, and I'll show you that what we need here. Okay, so obviously we don't need BW here, we'd be writing here frame anyway. Okay, so we have this if condition, and inside the if condition or the if block, what I'm going to do is that I'm going to create a variable named as font, and that font would be the font for timestamp. Okay, so what I would do, I would just write here font equals cv2 dot font underscore, and then I can have here Hershey and then underscore simplex. Alright, so this is one font. You can have other fonts here as well, it really doesn't matter. And then you're gonna have here the date, so let's call it date time, or something else, whatever you like. So date time is a variable in which we're gonna have a string method, and inside that we're gonna use a method, okay, in which we'd basically use the object date time. So what if we name this dt? All right, so that it you don't confuse it with the date time function that we'd be using. So we just write here date time dot now. Okay, so timestamp is gonna be current, so that's what we're gonna do. And after that, obviously the video is about running, so when the video is running, the time is moving. So if that would have been a still image, then the timestamp would have been still. But right now obviously the video is running, so the recording is running, or the video capturing is running frame by frame, so the time is going to be changing frame by frame as well, or you can say the timestamp is going to be updating frame by frame. Okay, so I hope you have got the point here. So now what we're going to do is that we're going to go to our next line, and we're going to have here frame. Okay, and this frame here, we're going to put it equals to one more thing that we need to do is that we need to have a colon here. Okay, so do not forget that, because in the end it would give you an error. So we write here frame, then we write here equal sign, then we write here cv2 dot, and after that what we're going to do is that we're going to use a built-in function which is like put text, and then we're going to write here frame, we write here comma, and then we write here dt, which is essentially a variable which contains the current time, date and time actually. And then we have here the size of it, 1000, and then we have the font, and then we write here 1, and then we have here the color RGB, and then we basically write here comma 2, and then we write here comma, and then finally we write here cv2 dot line AA. Okay, so now we come to our next line, and on the next line you're gonna have here this thing which is essentially cv2 dot IAMShow. All right, so yeah, frame, and then obviously the variable here is gonna be frame itself. And finally when we are done with that, what we're gonna do is that we're gonna have an if condition here, which would actually do nothing, but it would try to break it out of the loop. All right, so that if condition is actually going to be inside here. Okay, it is not going to be equivalent to that. And the other thing is that this scam.release, it's gonna stay there, and we're gonna remove this output.release from here because it has nothing to do in the code. And these two lines are gonna stay equivalent to while and cam because they are related. Okay, so that's how indentation is being done in the first place. So you need to make sure that your indentation is correct, otherwise it won't work the same way. All right, so I hope you have got the point. So now I think before we go to run our program, I need to explain it to you that what's actually happening here. And the idea is that it has 1, 2, 3, 4, 5, 6, 7, 8. It has actually 8 parameters, and each of the parameter it needs to be explained. So first of all, frame. So this is gonna be the image, or you can say in our case it is the video. Okay, on this video the text is to be drawn, so that requires to be first argument. All right, so the second thing is gonna be the text that we actually want to draw on our video or image, and that's coming from right here. Okay, so the third thing here, this one is org. Okay, it is the coordinates of the bottom left corner of the text string in the image or in the video, obviously in our case. The coordinates, they represent as tuples of 2 values, and that is basically x and y coordinates. All right, then we have a font basically, okay, as the fourth argument, and it denotes the font type. Okay, some font types are font Hershey simplex that we have used. The other one is font Hershey plain as well, so we can use that as well. So we can write here, instead of simplex, we can write here plain. All right, it doesn't really matter. So whichever you like, you can use that. Then we have 1, which is essentially the font scale, which is a factor that is multiplied by the font specific base size. Then we have the color RGB, as I have explained to you earlier. So you know, after that the 2, which is the second last argument, it is the line type. This is an optional parameter. It gives the type of the line to be used. Then finally we have cv2 dot line underscore double a. So this is an optional parameter. When it is true, you can call it a bottom left origin parameter, and when it is true, the image data origin is at the bottom left corner, otherwise it is at the top left corner. All right, so now what we're gonna do, other things you basically know what is IAMShow is and what this thing is for, this if condition here, and what this thing is for and what this thing is for. I have explained to you early as well, and we know that 0, it's gonna pick up our webcam. All right, so why don't we go ahead and we try to run this, and we see that what happens when we run this program and if the timestamp appears on our screen or not. So now what I'm gonna do is that I'm gonna run my program, and here you can see if I hit enter, this thing is gonna come here. Okay, so this is the book that I have in my hand, you know, How to Think Like Churchill. This is a great book, and I can revolve it around, and here you can see on top of that here, right here, if I bring the cursor, I have timestamp, and it's a moving timestamp. So the time is moving, and it is even showing the split seconds that it could show. So today, 22nd of December 2019, and the time is 11:04. All right, so I hope you have got the point. So now if I press K, you know, okay, so now let's move on to the next topic, which is drawing some of the geometry shapes. All right, so how do we do that? We just go here, and we have here import cv2, and the one thing that we're gonna import here, we're gonna import here, import numpy as np. All right, and the reason we are importing it because we're gonna draw geometrical shapes, and we're gonna draw it on a surface. So let's say we want to have a background with zeros. All right, so for that, what we would do would basically call it as image. All right, because a frame has to have an image in which it could be called. All right, so what we're gonna do is that we're gonna cross all of that, and instead of having cam.release here, because we are not capturing any resources, so we we are sure about that, we do not need to release them at all. So we write here cv2, and then we write here dot wait key, and then we write here 0. All right, so the thing is that first of all, I'm gonna write here inside a thing that is that would be related to zeros. Okay, that black image, you can say, that we're gonna have. So now I'm gonna write here image, and I'm gonna write here equals to, and then I'm gonna write here cv2, and then I'm gonna write here, not actually cv2, actually I'm gonna use here numpy. So I would write here np dot zeros, and then basically I can define the size. So all I have to do is that I have to give here some of the values. So I would write here 512, then I would write here a comma, then again I write here 512 comma, and then I write here 3, I put a comma here, and then I write here np dot uint 8. Okay, so now what I'm going to do is that I'm going to go to next line, and on this next line I'm just going to write here the IamShow method, which would basically show the image, all right, that we are trying to draw here. So all I have to do is that I have to write here cv2 dot IamShow, and then basically I name the window, which let's call it image. Then we write here a comma, and then we write here the variable imag, or image, you can say. So we save it, and we go back to our terminal, and we try to run our Python script. All right, so we hit enter, and right here when we would hit enter, you can see that we had a black background sort of thing. So let me just try to run that again. Here you can see that this is the black background here we have. All right, so let me just cross it. The idea is that I'm going to explain to you what every parameter is doing here, but first we'll try to draw different geometrical shapes. All right, so let's say that if I want to draw a line. Okay, so how do I do that? I would just simply write here imag, and then I would write here an equal sign, and then I would write here cv2 dot line. Okay, so this is a method that would help you draw a line basically, and once you have that, now you're going to pass a few of the parameters. So you write here imag from up there, and after that you write here a tuple 0, 0, x and y axis. Actually I'm going to explain to you everything that's happening here. Just first let me write all of that, and then let me show you the output. Then we'll discuss that what's happening with each method. Okay, so there are other methods coming as well, such as rectangle, circle, and ellipse. You know, these are the methods that we're going to discuss. So now what we're gonna do is that we're gonna write here another tuple, which would be something like this. Let's call it 147, comma, let's say 96, comma, and let's say 44. Then we have a comma, and the last argument we type in right here. Okay, so now if we save this, all right, and we go back to our terminal and we try to run our script, you can see that a line has been drawn here. Okay, and that 255 was for color RGB, and that is why it is blue. All right, so I hope you have got the point. So that's how you basically draw a line, and in case you want to draw a circle, so you can also do that. So let me just basically comment that, and would come here, and actually I'm just gonna copy all of that, and I'm gonna paste it right here, and instead of cv2.line, this time I'm gonna write here cv2.rectangle. Okay, the first argument is gonna be the same. Okay, and the second one, let's change it to, because this is gonna be a rectangle, so just write here 384, and then we write here 0, and then in the second argument, or in the third argument, we can have here 255 and 255. That is appropriate. And after that, we can have an arrowed line here. Okay, so the previous one was without an arrow, and this one is gonna be with arrow. Okay, so we write here arrowed line, and then we write here the image, and then we write here 0, and then we write here 255. So the third argument, we keep it as it is, and then we have this argument. We can actually change it 255, 255, and let's say 0. Okay, and then we keep it that way, 10. Okay, which is the length. So if we save it, and if we go back here, try to run our script, you can see that we have straight arrow. Okay, this is an arrowed line. Previously it was just a line. Now it is an arrowed line. And now if you want the shape, the geometric shape, to be a rectangle, you can also do that. All right, so just paste it. I have commented all those lines, and now if I paste it right here, all I have to do is that I have to write here cv2 dot rectangle. Okay, and then obviously I'm gonna have a few of these arguments which would remain same. For example, this imag, that would remain same. Then we would change this one 384 to 0. Then we would change the next one 510, and then we'd just write here 128, and after that we just gonna write here 0. We're gonna write here 0 as well, and here we're gonna write here 255, and after that what we're gonna do is that we're gonna have here 10. Okay, so now if we save it, we go ahead and we try to run our script. Here you can see that we have a rectangular right here. Okay, so we are done drawing the rectangular as well. So now let's go ahead and let's try to draw circle. Okay, so circle is something for which you can have, let me just basically comment this. I can paste it right here, and here I can have something like this cv2.circle. Circle is a method that would basically draw a circle for us. Okay, and here we would have g, the first variable that we're gonna have, and then we would have here 447, and then we'd have here 63, and after that we put a comma here. Here we are gonna be needing another element or another argument which is not gonna be in the form of tuple. So we have here 63, and then we are actually going to replace this one. Okay, actually that was the argument that we have replaced with 63 in the first place. Okay, so right now here what we're gonna do is that we're gonna write here 0, 255 and 0, 0, 255 and 0, and then here instead of 10 we're gonna write here -1. So now if we save it, we go back here. Remember that IMShow method is already reading IMAG variable, so we really don't need to do anything else other than writing the or calling the method or the function inside the IMAG variable. Okay, so now if we basically call our little script, you can see that this is the circle that we have drawn using Python code. Okay, and if you want to draw an ellipse, that is also possible. For that you have ellipse method, and you can do that using the ellipse function, which is essentially built-in function. All right, so let's not just get into it, or maybe we could actually write it down quickly here. So for that we just have to write here cv2 dot ellipse. All right, and when you do that, make sure that you have written the correct spellings, ELLIPSE. Okay, so that is for ellipse. The first argument is gonna be image without a doubt, and then the second argument you're gonna change it from 0 to 256, and then the third argument you're gonna change it from 255 to 100, and you're gonna change it to 55 to 50, and then actually you're gonna remove this, and now you're gonna write here 0, 0, and then you're gonna write here 180, then you're gonna write here 255, and finally you're gonna write here -1 or -1. Okay, so now you save it, you go right ahead, you try to run your script, and here you can see we have ellipse shape right here. Okay, I hope you've got the point. So that's how you basically draw different geometrical shapes. So now I'll explain to you what each method is doing and what their arguments are doing. Okay, so if we talk about drawing a line here, so you can do that by using this cv2.line method. The first argument here is the image. It is the image on which line is to be drawn, and that is obviously nothing but a black background. All right, so the second argument here, this is gonna be the starting point, and if you remember that we were starting it from 0 from this corner, top right corner. All right, so it is the starting coordinates of the line. The coordinates basically, obviously you're going to represent them in tuples. All right, then we have the end point, which was like 255 and 255, and we have used it. And after that we have the color BGR, which is essentially blue, green, red. So it was also a tuple, and the color that was drawn, I do not actually remember what was the color, but from here you can manipulate the colors. For example, if you would write here 25500, then it would have an exact blue color. All right, and then finally we have 10, which was not actually length, excuse me, I was wrong. I forgot about it. It is actually a thickness of the line in pixels. All right, So if we talk about arrowed line, the first is gonna be the image on which you're going to draw the line. This is gonna be the starting point, the second argument I'm talking about. The third argument is gonna be the ending point. This is gonna be the color, BGR, and this is gonna be the thickness of the line, okay, the last argument. The rectangle, the first argument here, which is IMAG, or image, it is the image on which a rectangle is to be drawn. Then we have 384 and 0, this is the starting point. Then we have 510 128, which is the ending point essentially. Then we have the color, and then we have the thickness, okay. And then finally we have the ellipse method, in which we have a image, and then second we have center coordinates. It is the center coordinate of ellipse. Previously we had the center coordinates of the circle. Then on the third argument, where you see 100 and 50, these are the axis length. It contains the tuple of two variables containing major and minor axis of ellipse. All right, major axis length and minor axis length, you could say. And then we have the angle of the ellipse. Okay, then we have the starting angle, and then we have the ending angle, and then we have the color, and then we have the thickness, -1, and there are two other parameters which are optional. One is line type and the other one is shift. You can have that. So line type is like it gives the type of ellipse boundary, and the shift, which is another parameter. This is an and also this is an optional parameter. It denotes the number of fractional bits in the coordinates of the center and values to the axis. All right, so that's how you draw different geometric shapes in Python. Hope you've liked it. So now let's move on to our next topic, which is essentially bitwise operators, or and, or, not, and XOR. So these are the topics of bitwise operators. So that's what we're gonna do now. We'd go to our code, and what I'm gonna do is that I'm gonna remove all of that from here. Okay, and obviously we're gonna need these two imports here. We can keep them, so we're not gonna use numpy here, but we can write it there anyway, so that's not an issue. So we write here img1, and I want to show you that I have two images downloaded on my desktop here. So here you can see that is image 1 and image 2. Alright, and these are the two images that we're gonna work on, and on these two images we would perform our AND, OR, and XOR operations. Okay, so we go to our code here. First of all, I want to read these two images, and the name of these two images, they are essentially, let me just go here and check once again, it's image 1 or image 2. Okay, so what I'm gonna do is that I'm gonna read here, so I would just write here I am read, and before that I would write here cv2 dot, and once I've done that I would write here brackets, double quotes, and inside these double quotes I'm gonna write here the name of the file, the image file, and the exact name of that is image_1.png. And for the second image, it's image_2.png. Alright, so what I'm gonna do is that I'm just gonna copy it. I come to the next line here and I paste it. Alright, here I change the name of the file, and here I change the name of the variable. So now we have these two images. So in order to check if these two images, they have been loaded properly, all we have to do is that we have to go here, and we can basically write here cv2.imshow, and here I can have the frame name, which could be image 1, and we can put a comma here, and we can write here the variable 1. Alright, the img1. Okay, so now what we are gonna do is that we're gonna copy it, we're gonna come here, and we're gonna write here image2 for the second frame and img2 for the second variable. So now we save it, we go ahead to our terminal, and let me just try to run our code here. So we just write here python hello.py, we hit enter, and you can see that we have two images, image1 and image2. So image1 is like half black and half white, or you can say 50% black or 50% white, and image2 has like white circle and a black background. Okay, so just remember these things. So now what we're gonna do is that we're going to perform OR and XOR operations on these images. Okay, so first of all, let's say if we perform AND operation on these two images, for that we have a built-in method, or you can say the built-in function that we would use. So let me just comment these two lines right here, and what I'm gonna do is that I'm gonna write here img1, excuse me, not img1, actually I'm gonna write here AND, which is essentially the variable name, but I can write here AND bit, and I can write here equal sign, and then I would write here cv2 dot bitwise, which is a built-in function, and then I pass two arguments, which would be image2 and image1. Okay, so now what I've done, I have performed an AND operation on that, and if we see what an AND operation is, this is the table of that. Okay, so if you see that these images, they would have matrices and they would have bits. So these two images, these bits are going to collide with each other, and they're going to produce the result according to this AND structure or AND table. Okay, so in order for the output to be 1, both of them have to be 1. Okay, so now let's go ahead and let's see what happens when we basically show that AND bit or the operator. So for that, what we would do, we'll just go here, and the frame name is gonna be AND, and here instead of having image2, we're gonna have here the variable name, which is essentially AND underscore bit. Alright, so if we save it, we go ahead and we try to run our script. Here you can see that we have AND operator in this way. Okay, so you can see that we have merged image2 and image1, and the AND operation was performed here something like this. Okay, so in case you want to compare that with the image1 and image2, you can simply uncomment this, you can save it, you can go ahead to your terminal and you can run that again, and here you can see that with AND operation you've got this result. Here you can see that when these basically two images, they have collided with each other using the AND operation, it has given us this result. So now what we can do is that we can perform the same function for OR as well. All we have to do is that we have to go back here in our code, and we have to just simply copy this AND bit, and after copying this we can come here and we can paste it right here, and after pasting it we can simply change the name from AND bit to OR bit. And also what we can do is that we can change the AND here to OR as well. Okay, so now the OR operation would be performed on it, and that would be performed according to this truth table that you see here. In order for the output to be 1, only any one of the input has to be 1. Okay, so now if we go here, if we try to basically have here cv2.imshow here, and here we have OR bit, and here the frame name, let me just cross it. So the frame name I was talking about, if we do something like this OR, and if we save it, we go ahead to our terminal, and if we try to run it, you can see we have four sort of outputs. So right here you can see that with the OR we have all the side white here, and the white side of the circle remains the white as well. So here we have the circle, but we cannot really see it because it is basically indulged into the white color. Okay, so you can see that nothing has changed. One would give you 1 on the output as well if you have 1. All right, so I hope you have got the point. So now what we're gonna do is that we're going to perform the exclusive OR or the XOR operation, and in order to do that, all you have to do is that you have to basically copy this. All right, so let me just copy it for you. So we copy it, we come here and we paste it, and instead of OR bit we write here XOR bit, and here instead of having bitwise OR, we have bitwise XOR. Okay, so now if we save it, instead of saving it, one thing you have to do is that you have to make sure that you are showing the image. If you don't show the result, you won't know if the XOR operation was successful or not. Okay, so you just save it, you go back here to your terminal, you try to run your script, and here you can see that this is what you have got using XOR, and here you can see the truth table of XOR where you the 1 1 only this is gonna change. Okay, that's gonna be 0. Other than that, everything remains same as the OR, and here you can see that's why we have got this result with XOR. Okay, that makes sense. So one last thing that I would like to tell you, that is basically the NOT bit or the NOT operator, and yeah, that's how you perform it. So let me just quickly show you that how you can perform that. So you go here, you just simply paste it. Let me just comment everything else so that you can focus on NOT. So I am just going to comment it. Okay, so comment till here, and I am also going to comment from here till here. Okay, so the only thing that we're gonna show right now, it's gonna be those two images and the NOT operator. So from here we can comment actually. Okay, so now what I'm gonna do is that I'm going to have NOT bit here, so I would just write here NOT bit, and the idea is that NOT bit only is going to be applied on one image. So let's say if we apply that on image 2, then it is going to be the reverse of the original image. So let me just have here NOT bit 2 or NOT 2 bit, and let me just paste here image 1. Okay, so the one more thing that you need to do is that you have to have an IAMShow method for that, and here you're gonna have that. Okay, so here you can basically change the name of the frame. Let's call it NOT 2, and let's call it NOT 1, and here you can have NOT bit, and here you can have NOT 2 bit. All right, so that's how you basically perform the NOT bit operation. So let's just save it, and let's go ahead and let's try to run our script. Okay, so let me just close it quickly, and let me just close all the other results that we see here quickly. So I crossed. So now what I'm gonna do is that I'm going to run my program, and that is gonna be Python hello.py. I hit enter, and here you can see that for the first NOT, that was for image 2, which was NOT 1, you can see that we have reversed it, and in image 2 we had black background and the white circle, but as if it's inverse, which is NOT 1, we have white background and black image. Similarly, if you see right here, we have image 1, which was black and white, and in its inverse we have white and black. Okay, I hope you have got the point. So that was related to the XOR, OR, and NOT operations in OpenCV. So now let's move on to our next topic, which is essentially split and merge. So the idea is that when you're basically trying to split an image, that image would be it would actually be splitted into channels, 3 channels usually for one image. And once it's been like splitted in those 3 channels, then you can basically merge these channels, these 3 channels, to use the merge function, and the image would be back into its original state. Okay, so split function is basically used to split the image into its basic channels, which are usually 3 RGB, you can say, or you can call it, you know, whatever you want, or maybe you can call it HSV as well. And then basically you use the merge function to combine these 3 channels, and then you get the image, the same image that you actually have performed the split function on. So that's what we're gonna do today right here. So what I'm gonna do is that I'm going to remove all of that. All right, so first of all I have to read the image. So I'm going to write here image equals to cv2 dot imread, and then inside this imread I'm going to pass the image, and the image is gonna be cat.jpg, let's say, which we have on our desktop. So the next thing that you are gonna do is that you want to know that how many channels and what is the shape of the image that you have. So for that what you can do is that you can write here image.shape, and it would print out the details about the image, like how many rows you have and how many columns and how many channels are there. And once you know that, so what you can do is that you can have here RGB, and these would be the 3 channels, and now you want to split your image into these 3 channels. Okay, so for that what you would do, you would write here you know, something like cv2 dot split, and then inside of that you would pass the image. Okay, so that's how you basically split an image. And if you want to merge it, then in that case all you have to do is that you have to write here cv2, and then you write here dot merge. But the idea is that you want to store that into a specific variable. So you just write here image, and then you write here cv2 dot, and after that dot you write here merge. And once you write here merge, what you're gonna do is that you're gonna write here brackets, and in these brackets you are going to write here H or maybe R G B. So whatever your variable names are, you're gonna write them right here. Okay, so here using the split function we have divided it into 3 channels, and here we are merging the image from these 3 channels into one image. And once we have done that, all we have to do is that we have to come here and we can write here cv2.imshow, and then we can have as the first argument the name of the frame, and that could be image, or you can call it cat. And after that here you're gonna pass the variable, which is essentially image. All right, so if we save it now, we go back to our terminal. Let me just clear it. So we go to our terminal, and now we try to run this. Okay, so we write here python, then hello.py, we hit enter, and now you can see that we have that cat image from our desktop. And in addition to that, you can see we have here 960, which are like the number of rows in the image, and then we have 640, which are the number of columns in the image, and then we have 3, which are like number of channels present there. Okay, so 960 rows, 640 columns, and 3 channels we have in our program. And if we go here in our program here, you can see that these are the 3 channels that we have splitted using the split function in the first place, and then we have combined it using the merge function. So that was the functionality of splitting and merging in OpenCV. Okay, so our next topic is scaling on an image. All right, so scaling is basically that you can resize the image according to your desire and you can scale it. So for example, if there is an image and we want to reduce the image or resize the image to the 60% of the original size, then we can actually do that. And this would basically, you can call it resizing or scaling on an image. All right, so let's do a practical example. We have a cat image on our desktop. That's what we are gonna use, and here we are gonna code. Okay, so for that, what we would do, basically we're gonna need this. So let me just remove all of the above from here. So I remove that. So now what I'm gonna do is that I'm gonna write here a code. So obviously we don't need that in NumPy, but if you keep it written here, it doesn't really matter. Okay, so we just need CV2 for this program or for this code. So here what we do, we create an image variable, and in here we basically read that image, and that is essentially cat.jpg. okay, so how do I know that? If I ls here, you can see that I have cat.jpg image on my screen on my desktop. Okay, so I have that. So after reading this image, what I'm going to do is that I'm going to write here the dimensions actually. So I want the dimensions of the image, which would be the original dimensions, you can say. So what I'm going to do is that I'm going to write here original dimensions of image, and then after that what I can do is that I can put a comma here and I can write here img.shape. all right, so this img.shape, img is basically, it is related to this one, the variable here, the image that we are reading here, it is stored in img, and now we are writing here img.shape, which would actually print out the dimensions of this image that we are reading. Okay, so now we go on to the next line, and the next thing that we want to do is that we want to set a percentage for scaling the image. So we can write here scale, and then we can write here percentage, or PRC represent percentage here. So what we can do is that we can give a scale, and let's say we give it a value of 60. So it means that it would be, the scale would be the 60% of the original size or the original dimensions that we have. Okay, so now what we can do is that we can multiply the original dimensions of the image with the percentage, and the original percentage, we would get it by 60 divided by 100. Okay, so that is a kind of a formula that we're gonna use, and let's see how we can use it. So we would just write here, first of all, we're gonna work with the width. So we just write here width, and then we can write here integer, and in here we can write img.shape. So basically img.shape is related to the image dimensions, and if I write here 0, it would be for height, and if I write here 1, it would consider it for the width. So now I'm going to write here asterisk, which represent multiplication, and then obviously we're going to write here scale percentage, and then we basically divide that thing with 100. Okay, so that thing is like this. All right, so I hope you have got the point. And now we want to do the same thing with the height, except we're gonna change the index to 0 and we're gonna change the variable name as well. So here we can write here 0 for height, and here what we're gonna do is that we're gonna change the variable name, and that is gonna be essentially height. Okay, so that's how you multiply it and you get it. So now what we're gonna do is that we are going to use a built-in method, and this built-in method we'd use for resizing the image. Okay, so now what we're gonna do is that we're gonna use a built-in method. This built-in method is basically known as resize. Okay, resize image. So for that we'll just write here the variable name, let's call it resized, and then we write here equal sign, and after that we just simply write here cv2 dot resize, which is a built-in method that we're using to resize the image. And then what we're gonna do is that we're gonna write here img, then we're gonna write here dim, and then after that we're gonna put here a comma, and after that we are going to write here interpolation, something like this, interpolation equals, and here we write cv2 dot inter area, and make sure that all of this inter area is in capital. Okay, so I explained to you that what these arguments are. So here you can have multiple interpolation methods. We are using inter area, which is used when we need to shrink an image. All right, and if if you want to have an efficient image, then you can use intercubic. That is slow but efficient. And if you want to, if you would use here interlinear or inter_linear, that would be basically it is primarily used for when basically you're zooming in the image. Okay, so when zooming is required, in that case inter_linear is what you're going to use here. Okay, so if you don't use any technique here, then the default interpolation technique is inter_linear. All right, so I hope you've got the point. So now let's move on to the next thing. So if you're wondering what this dim is, this is basically the tuple of height and width, which we have not actually defined it here. So what we can do is that instead of defining, we can write directly here something like this. We can write here, so we can write here width comma height. Okay, so that is the tuple. You can create a variable and then store that tuple in that variable as well. You can do as you like. All right, so now what we're going to do is that we are going to print out the resized dimension. So for that we just write here print, and then we say resized dimensions of image, and then we put a comma here, and then we write here image.shape in the similar way. And then finally we are gonna print out the resized image. Okay, so the resized image, in order to print out, what you have to do is that you have to write here cv2 imshow, and in here you're gonna basically name the frame, and you can name it like, let's say, resized image, and then we can put a comma here, and then we can write here resized. Okay, and the thing is that here instead of having the img.shape, we're gonna write here resize.shape, because this is the resized image for which dimensions we are looking for. If we would have been looking for this image's dimensions, then we would have shown this one. Okay, so I hope you have got the point. So now what we're gonna do is that we're gonna save it here, and we are also going to print out the original image. So what we can do is that we can copy this, we can come here and we can paste it right here, and here we can write img, and here we can write original image. Okay, so now it is basically going to print out two images. All right, and one is going to be the original one, the other one is going to be resized image. And before we go on to run our program, one mistake that we have made here is that we have not written here cv2.imread, and that's what we need to do right here. And now we are all done. So if we save it now, we go back to run our program. So here you can see that this was the original image, right? And now without losing it, we have resized it to the 60% of its original size, and this one is the resized image. So if we talk about the dimensions right here, the dimensions for original image, they were 960 rows, 640 columns, and there were 3 channels. And here you can see that we have reduced the image by 60% of the original size, and you can see here now we have 576 rows, we have 384 columns, and we have 3 channels. So that's how basically you scale on an image, and it totally depends upon you that what size you want to resize it on. So for example, if you want to scale it by 10%, you can change the value right here to 10%, and if you want to scale it to 80%, you can also do that. So it totally depends upon you that what value you're gonna choose. So that's it for scaling on an image. So let's move on to our next topic, which is essentially edge detection. In the image, you can basically detect the edges available there, and what would happen is that we'd write a code that would only draw the edges after detecting in the image. So for example, we have a cat image on our desktop, and only the edges which are like there in the video or in the photo, those are the edges that we would detect, and ultimately we'd print that out on a black screen. Okay, so let's go ahead and let's try to do that. So for example, here we have the code. So what I'm going to do is that I'm going to just remove all of that. First of all, we're going to read that image. So we'll just write here cv2 imread, and then I would write here cat.jpg. Okay, that is the image that we're going to read. So after reading this image, what you have to do is that you have to use a canny algorithm, which is a built-in method inside the cv2 library, which we will use, and we'll try to basically extract the edges out of a picture. So what we do, we can write here edges, and then we can write here equal sign cv2 dot, we call that method, which is canny, and it would take 3 arguments. First is gonna be the image, second is gonna be 100, second we'd write here 100, and then we'd write here 200. So here we have image first, and then we have edges threshold 1, and then we have a threshold 2 of that, and then we come here on the next. So now what we're gonna do is that we're gonna print out here the image that we have identified the edges of. So now we'd write here after cropping edges we have, and then we can basically put a comma here, and we can write here edges. So what we can do is that we can print out here the original image as well. So for that we just write here show, and then we can write here ing. So now if we save, and one thing that you can do is that you can have here the window name, which could be something like original image, and now we are all done. So now we'd save it, and we go back to our terminal, and we try to run our script, which is python hello.py. So here you can see that this is our original image, and these are the edges that have been detected on the image, and those edges have been drawn here. Okay, so you can see that here we have the rest of the body of the cat, but you know, those are not edges. So edges are right there on the face of the cat, and that is like eyes here and a little bit of nose, and you know, these you know, ears of the cat. So what we can do is that we can change the image as well. So for example, instead of having cat.jpg, we can have python.png, which is an image on our desktop here. Let me show you first here. So if we ls here, we have this python.png image on our desktop. If we have been taking it from any other folder or any other directory, we would have pasted here the whole path, right? So now we have that python.png. If we go back to our terminal and we try to run our code, you can see that this is the original or the genuine image of the Python, and the edges have been detected. And after taking out the edges, and if we print them out here, you can see that these are the edges that we have here. Okay, so I hope you have got the point. So that was related to the edges, identifying the edges and then printing them out in a separate image, and that's what we have done. Hope you've liked it. So now let's move on to our next topic, which is simple image thresholding. Okay, so the next topic is simple image thresholding. So thresholding, if we talk about that, it is a technique in OpenCV which is the assignment of pixel values in relation to the threshold value provided. So in thresholding, each pixel value is compared with the threshold value. If the pixel value is smaller than the threshold, it is set to 0. Otherwise, it is set to a maximum value, generally 255, and 0 stands for black color and 255 means white. So thresholding is a very popular segmentation technique used for separating an object considered as a foreground from its background. A threshold is a value which has two regions on its either side, one below the threshold or above the threshold. In computer vision, this technique of thresholding is done on grayscale images. So which means that whatever image we are going to read, we're going to make it grayscale image. All right. So now let's go ahead and let's try to do a little bit of code regarding thresholding. So the idea is that we have multiple methods in which we can perform thresholding. Okay, so let's see what they are and how we can actually work with them. So first of all, we need this CV2, so we'll just keep it that way. So so now what we're going to do is that we are just going to remove all of that. All right, so here what we can do is that we can write here image, and then we can write here equals cv2 dot imread, we can write here, and then we can read an image. So let's say that we try to read python.png, and then we come to the next line, and here what we try to do is that after reading the image, we want to make it a grayscale. So what we can do, if you remember, I've told you previously that there are three modes. One is 1, and one is -1, and one is 0. So 0 is for grayscale, 1 and -1, they both are the same. And even if you don't write 1 and -1, it means that the same, that image is going to be read as it is. Okay, so now what we want to do is that we want to take that image and we want to read it as grayscale image. So what we would do would just write here 0, and now it would read it as a grayscale image. Okay, so now we want to perform different sort of thresholding. So all we have to do is that we have to write here return first, okay, for the returning value, and then we can write here thresholding values. Okay, so we can say thresholding 1 value, and we can put it equals to let's say we write here cv2 dot threshold, which is a built-in method that we are going to use, and in here we're going to pass different arguments. So first argument, we're going to pass image, then we're going to pass the value. If let's say the value is less than 50, then it's going to make it 0. If it is greater than 50, then it's going to make it 255. And now what we can do is that we can write here CV dot thresh. If in fact this has to be in a greater way, so you can write here thresh, okay, all of that has to be capital, and then you can write here binary. So thresh binary that you see here, what it does that if the pixel intensity is greater than the set threshold value, it's you know that we've set to 255, otherwise it would basically set it to 0. Okay, so if the pixel intensity is greater than the set threshold, then it would set it to 255, otherwise it is going to set it to 0, which is essentially black. Okay, so what we can do is that we can go ahead and we can try to write print it out, the resulting image, and then we can see that what do we have on our output. So first of all, we can have our image, which is essentially img. We first of all we print that out so that we can see that what was the real image and what is the value of threshold 1 on which we have performed thresh binary. Okay, so what we can do is that we can write here show, and then we can write here original image, and then we can write here comma, and then we can write here img, which is essentially the variable name in which the original image is stored that we are reading. All right, so after that what we are supposed to do is that we can write here cv2.imshow, and then in here we can write here threshold 1, which is essentially the value. So before that we need to give the window the name, so we can call it threshold 1. And now what I need to do is that finally I need to add those two lines, cv.wait key, okay, if any of the key would be pressed, and then we want to write here actually this is cv2, and then we write here cv2 dot destroy all windows. Okay, so that's how you do it. So now let's go ahead, let's save it, and then try to run our program, and let's see if that works. So now when we run it, you can see that the value of threshold is 1 right now. Okay, it must have been greater than the 50, which was the set threshold, and that's why it has set it to 255, and that's why you see the threshold 1 value, which is 255, and that's why we have the entire white background here. Okay, so I hope you have got the point. So now what we're gonna do is that we're gonna go to our code here, and in the similar way we're gonna perform other methods such as thresh binary inv. Okay, so let's go ahead and let's perform that, and let's see what happens. So what we are gonna do is that we are just simply going to copy this, okay, from here, and we are just simply going to paste it right here. Okay, so right now you can see that what we can do is that we can change the value of the variable from threshold 1 to threshold 2, just to differentiate that this is another variable. And another thing that we can do is that we can set the value of the threshold. So let's say previously it was 50, so now let's say we set it to 200. Okay, then after that what we have is thresh binary, so cv2 thresh binary and then underscore inv. Okay, it stands for inverted or opposite case of the thresh binary. So what's gonna happen as that it is gonna be the vice versa of this case. So let's see that what we get as the output for that. So what we would do, would just simply copy this and we'd paste it right here, and instead of threshold 1 we just change it to threshold 2, and we are all set. So now we'd save it, we go back to our terminal, we try to run our code and we hit enter. There you go, you can see that this time instead of having like entire white background, we had black a little bit here. Okay, so the value must have been greater than the value must have been less than 200 for this area, so that's why it has turned it to white, and the value of this region must have been greater than 200, and that's why it has been set to black. Remember that it was basically the vice versa of threshold 1. Okay, so now what I'm gonna do is that I'm gonna go here and I'm gonna do the same thing. I'm gonna copy this, and this time I'm gonna perform thresh trunk. Okay, so now what we would do, would just go there here. Actually, let me just go there and paste the same line of the code right here. In fact, we're gonna just copy this and we paste it right here, and instead of having threshold 2 we have threshold 3 here, and then here we can set any other value, like let's say 127, and here we can write thresh and underscore trunk. Okay, so what it does that, I'm talking about this thresh trunk, CV2 thresh trunk. So what it does that if the pixel intensity value is greater than the threshold, it is truncated to the threshold. The pixel values are set to be the same as the threshold. All other values remain the same. Okay, so if we now go ahead and we try to print out the threshold 3 as well, so we just go ahead, we save it, we come here, and here in this line we paste it. Here we have threshold 3, and here we have threshold 3 as well. So if I save it, I go back to my terminal, I try to run it. Now you can see that this is the threshold 3 value that we have got. It has set the value of the pixel as same as the value of the threshold. Alright, so there is another threshold which is basically thresh to 0. Okay, so let's see that what it does. So basically the pixel intensity is set to 0 in this case for all the pixel intensity less than the threshold value. So every value which is less than the threshold value, it's gonna be set to 0. Alright, so let's see how do we do that. So for that, what you can do is that you can just simply copy that, and here we can have threshold value 4. So here we can write 4, and in here we can actually change the value of the threshold. So here we keep this everything the same, except we just simply write here, instead of trunk we just write here to 0. Alright, so the next thing that we can do is that we can just simply copy this and we go ahead, we try to paste it. So now we save it, we go ahead, we try to run our program, and here you can see that we have multiple thresholds, but I forgot to change the value of that. So we have threshold 4, and we need to change the value of this as well. So we save it, we go back, we run our Python script, and there you go. So this is our threshold 4. All the pixel values less than the threshold value, they have been set to 0, and that's why most of the portion you see here is black. Okay, and here you can see these were the threshold 3, 2, and 1. So now let's go ahead and let's try to work with the threshold 5, which is the last one, and this is basically the inverse of the 0. So 20 underscore inverse. So what we're gonna do is that we're just simply going to copy this entire line and we're gonna paste it right here, and instead of threshold 4 we're gonna change the variable to threshold 5. We keep everything the same and then we write here INV. Okay, so as the name suggests, it is the inverse of this thresh to 0. Okay, so whatever this thing threshold 4 does, it's gonna invert it. Alright, so now we come here and obviously we try to print that image, because if we won't print it we won't get the output and we cannot know that what happened to threshold 5. So if we go here, we save that, we come back to our terminal, try to run it. There you go, this is our threshold 5, which is entirely opposite of the threshold 4. Okay, so whatever threshold 4 is doing, it is doing the inverse of that. Alright, so I hope you have got the point. So this was like simple thresholding. So now let's move on to our next topic, which is essentially adaptive thresholding. So adaptive thresholding algorithm, it provides the image in which threshold values vary over the image as a function of local image characteristics. So adaptive thresholding, it involves two steps. One is basically divide image into strips, and the second one is that apply global threshold method to each strip. So in adaptive thresholding, threshold depends on both f of xy and p of xy. Adaptive thresholding changes the threshold dynamically over the image. Adaptive thresholding typically takes a grayscale or color image as input, and in the simplest implementation outputs a binary image representing the segmentation. Okay, so that's what we're gonna do right now, and we're gonna go to our code and we're gonna try writing code for that. All right, so for that what we would do would just simply go here. Let me just remove everything from here. Actually we don't need to really remove them, but let's do it anyway. So let me just remove that and let me just remove this from here. Okay, so we have an image here, we are reading it, that is essentially python.png, and we are having it in a grayscale. Okay, how do I know that? Because I have put 0 here. Okay, so once it is converted into the grayscale, now we can actually go ahead and we can perform different thresh methods which are available. One of them is thresh binary, adaptive thresh mean C, and you know, we have adaptive thresh Gaussian C, things like that. Okay, so that's what we are going to do. All right, so what we're gonna do is that we're gonna have here threshold 1, and here we have the image, and then we have 127, let's say, and then we have 255, and we have thresh binary here, and you already know that what thresh binary is. Okay, so we're gonna keep it that way. So the next thing that I'm gonna do is that I'm gonna go to the next line, I'm gonna copy it, I'm gonna have threshold 2 here, and inside here, instead of having thresh binary, I'm going to have adaptive thresh mean underscore C. Okay, so I'm gonna write here adaptive underscore thresh underscore mean underscore C. Okay, I'm gonna write here mean underscore C. So the idea is that it is gonna have more to it. Okay, so the more arguments that we need to write down here, and the thing is that we are gonna remove this one from here. All right, so we have 255, and then we have the cv.cv2 adaptive thresh mean underscore C, and now we're gonna have thresh binary. Okay, so I'm just gonna write here cv2 dot thresh underscore binary, and then after that I'm gonna put a comma here, and then we write here 11, and then we write here 2. Okay, so I'm gonna explain to you in a while that what these arguments are and what they do, but first I would keep on writing, and I would have here another threshold. Let's call it threshold 3, and in this one we're gonna write here thresh adaptive thresh Gaussian C, and for that what I would do, that I would go here and in here I'm just gonna write here adaptive thresh, and instead of having here mean, I'm gonna have here Gaussian. Okay, so I would just remove that and I would write here Gaussian, G-A-U-S-S-I-A-N. okay, and rest of the things remain the same. So now we show the original image, and then we show the threshold 1, which is basically it is thresh binary, and then we come here and let me just copy paste this one. So we do that for threshold 2. Okay, so we come here and we're gonna write here threshold 2, and here threshold 2 as well, and after that we're gonna come here, we're gonna paste it again, and this one is gonna be threshold 3, and this one is threshold 3. So what we can do is that we can put here with the name we can write something which could point that this threshold is related to what we are looking for. So let's call it threshold 1 binary, let's call it threshold 2 mean, and let's call it threshold 3 underscore Gaussian. Okay, and then we're gonna give here the threshold type, then we give here the block size, which is essentially 11, and then here last one 2, it is a constant. Okay, so if we talk about this one, which is an adaptive method, there are basically 2 adaptive methods that we have. So one is adaptive thresh underscore mean underscore C, which says that threshold value would be equals to mean of the neighborhood area values minus constant values. Okay, so whatever the values of the neighborhood area values are gonna be, we have to subtract them from the constant, which is essentially 2. Okay, so the other thing, in other words, you can say that it is the mean of the block size multiplied by a block size, neighborhood of a point minus constant. Okay, so if we talk about adaptive thresh Gaussian C, then this one, it's like threshold value equals Gaussian minus weighted sum of the neighborhood values minus constant value. So in other words, it is a weighted sum of the block size multiplied by block size, neighborhood of a point constant minus 1. So for each of them, I'm just gonna write here the formula, and then I'm going to comment that. Okay, so I would just write here threshold value, whatever it is, so it's gonna be equals to for thresh mean C, it's gonna be equals to mean, let me just write here, mean of the neighborhood values. Okay, neighborhood values minus it's gonna be constant. Okay, so in other words, you can call it block size multiplied by block size. Okay, so after that excuse me. And in case of the Gaussian, it's gonna be something like this. So we write here threshold value, then we write here equals to, and then we write here Gaussian weighted sum, Gaussian weighted sum of neighborhood values minus, it's gonna subtract it from the constant value or constant. Okay, so you can put brackets here, so it's like, you know, it's together. So we can put one bracket here as well. So I hope you have got the point. So that was it. So that was the difference between adaptive thresholding methods, and obviously you know what simple thresholding methods are. We have discussed them in the previous topic. One thing that I'm forgetting, which is here you need to write here CV2 dot adaptive and then basically threshold. Okay, so this is a standard practice, otherwise it would give you an error. So here you also need to write here adaptive threshold. Okay, so make sure that you don't make this mistake, because this threshold, it takes 5 arguments at max, and this adaptive threshold, it can take up to 6 arguments. Okay, one more thing that you need to do with adaptive threshold, you also need to remove these return here, because with the adaptive threshold methods you don't need to have these return value. Okay, so now if we save it, we go to our terminal and we try to run it. So here you can see that we have the output. So this one right here, you can see that this is the original image right here that we have done grayscaling on. All right, and right here you can see that this is threshold 1 binary, so this is like simple thresholding, and this one is adaptive mean thresholding. Okay, and this one is adaptive Gaussian thresholding. So you can see that the borders or the edges here in this image, they are a little bit darker, but if you see in the Gaussian, they are a little bit lighter. Okay, so you could clearly see the difference between simple thresholding, that it is, you know, it is not really neat, but if you go ahead and you see the adaptive thresholding, it is really neat and clean. All right, so yeah, that was it. So you can also say that simple thresholding was related to the background, and it has more to do with the fill colors, but the adaptive thresholding, it has more to do with the borders and the linings, etc. Okay, so you can say that. So I hope you have got the point, you have enjoyed this. So now let's move on to our next topic, which is essentially detection of geometric shapes. How do we do that? We're gonna look into it. So let's go ahead and let's try to do the code for it. So what we're gonna do is that we're gonna have a shape, an image which would have different geometric shapes, and then we'd basically identify those shapes accordingly. All right, so what we're gonna do here is that we're gonna go ahead and we're gonna write here, first of all, we're gonna load the image which would have different shapes. So let me show you that. So for that, I would write here cv2.imread, and then in here I would basically write the name of the image, which is essentially shapes.webp. all right, so this is the image that basically you know, it is located on my desktop, so I don't need to put in a complete path of the directory here. I just write the name of the file, because the script that I'm writing here, that also is located in our desktop. Okay, so now what I'm gonna do is that I'm gonna write it. First of all, I have read it. Now I'm gonna print it out. So for that, what I would do, I would just write here cv2.imshow, then we'd write here the frame name or the window name, so let's call it shapes, and then basically we just write here img. So now if we save it, we go to our terminal. Let me open that. Somehow it got closed. So I'm gonna go to my desktop because that's where my script resides. Here we have a spelling mistake, so we just write here I am show. So we save it, we go back to our terminal, we hit enter here, and you can see that these are the shapes available here. We have a triangle, circle, square, and hexagon. So I'm just gonna basically cross it. So now we'll just write a code here to identify these shapes from this image. Okay, so for that, what we would do first of all would basically we have this image, so we're gonna convert this image into gray. So we just write here img gray or imgg. So G capital here represents gray. Okay, so we just write here CV2, then we write here dot CVT color, and after that we basically write here brackets, parentheses actually, and in here we pass different arguments. So first argument is gonna be the image, and obviously it is not all capital. Image, this image right here is this variable. Okay, so I hope you've got the point. So now what you want to do is that you want to write here CV2 dot, and after that you're gonna just write here color underscore BGR2 gray, and that would all be in capital. So you write here color underscore BGR2, and then you write here gray in capital. Alright, so what it would do, it would basically convert it into a gray scale image. Okay, so now what we're gonna do is that we're gonna go to our next line, and here we're gonna have a return statement, and then we would write here thresh. Okay, thresholding we're gonna use, so we just write here th as the variable, and then we just write here cv2 dot threshold. Okay, and if you know that in the previous topics we have discussed adaptive threshold and we have discussed simple threshold, and this one here right here is the simple threshold. So now what we're gonna do is that we're gonna write here img gray, the image, and that is we're gonna write inside the parenthesis, and after that what we're gonna do is that we're gonna write here 240, and if this thing is less than 240, then it would turn it to 0, otherwise it would turn it to 255, which is essentially white. Alright, so after that we apply the thresh binary, and I've explained to you in previous topic in the simple thresholding that what that is, so I'm not gonna jump into the explanation of that right now. If you have skipped it, go ahead, watch the previous topic, alright, in the same video. So now we're gonna go to our next line, and in here we're gonna use contours. So I'm just gonna write here contours first, and then we're gonna use the find contours method, and I'm gonna explain to you both of them. So what are contours and what are contours method? So we just write here contours, and then we have return here, and after that we just write here cv2 dot find contours. Okay, remember you don't have to make the spelling mistake, so you write here C-O-N-T, and then you write here O-U-R-S, then you put here brackets. Alright, so it doesn't matter if you have it like the variable spellings are wrong, it won't matter, but here you need to make sure that you write here find contours like this. And after that you write here as the first argument, you're going to write here the thresholding variable, which is essentially th, and after that you write here cv2 dot retr underscore tree, which is a mode here, and this one here cv2, then we write here dot chain prox underscore approx none, which is essentially a method. So this right here is the thresholding variable, this is the mode, and this is the method. Alright, so now I'm going to explain to you that what are contours and what is this method. So the idea is that contours are defined as the line joining all the points along the boundary of an image that are having the same intensity. Contours come handy in shape analysis, finding the size of the object of interest and object detection. So OpenCV has find contours function that we have used that helps in extracting the contours from the image. It works best on binary images. So first of all, you have to apply thresholding techniques in order to get those binary images. Okay. So we also have contours approximation method that we're going to use next. So contours are the boundaries of a shape with the same intensity. We know that. It stores the x and y coordinates of the boundary of the shape, but does it store all the coordinates? That is the question. That is specified by this contour approximation method that we're going to use ahead. So if we pass cv2.chainApprox none that we have passed here, all the boundary points are stored. But actually, do we need all the points? For example, if we have to find the contour of a straight line, we need just 2 endpoints of that line. This is what cv2.chainApprox simple does. Okay, so if you write here simple, in that case it would just find 2 points, the starting point and the end point. And writing here chainApprox none, it would save basically all the points. Okay. So I hope you have got the point. So the approximation method, we're gonna use it right ahead. Okay, so do not worry about that because I'm gonna explain to you. I'm gonna explain that to you in detail. All right. So now what we are gonna do is that we're gonna come here and we're gonna have a for loop here. So we'll just write here for, and then we write here contour. And then we write here in contours, and then we have colon here. And now inside the body of the for loop, we are just going to have a variable named approx, and then we write here equal sign, then we write here cv2 dot then we write here the method, which is essentially approx polytp. All right. So this one here, poly. So now in this method, what we're gonna do is that we are going to pass contour first. Then we are gonna have here epsilon, the value of epsilon, it could be like 0.01. Then you're gonna have static here, and you're gonna multiply it by the arc length. All right, arc length is basically and then you're gonna multiply it with the arc length. Okay, so we have a method in cv2 library which would basically get arc length for us. Okay, so as we are using the method chainApprox none, so it's gonna store all the contours, so we need the arc length of all the contours that we have. And in here the second argument in the arc length method, we're gonna have it as true. Okay, and the last argument in the approx polytp method, it's also gonna be true. Okay, so after that what you're gonna do is that you're gonna use the draw contours method here, so that you would just write here cv2, and then you write here dot, and after that you write here draw contours, and then you're gonna write here img, and after that you put a comma here, you write here approx, and then you put here a comma, and after that you go ahead and as a third argument you write here 0, and as a fourth argument you write here 0, a tuple of zeros actually, and we have a tuple of 3 zeros here, and as the last argument we're gonna write here, this is basically the pixel length, and let's call it 5. And then I'm gonna specify the x and y coordinates here, so we just write here x, and then we use that approx, and then we write here dot ravel, which is a built-in method, and then I'm just gonna write here 0. Okay, so which is basically a position of for x coordinates. All right, so then I write here that same thing again, approx revel, and this time here I basically write another thing here, 1. And one more thing that I want to do is that I want the shape to be like a little bit up the surface of the image. So for that, what I can do, I just write here -10 here. Maybe so now the name that would be on the surface of the object, it would just slightly be above than that. Okay, so now what I'm going to do is that I'm going to check now the length of the approx method using it. So if the length is like 3, then it would be triangle. If the length is 4, then in that case there are basically 2 further things. Either it is a rectangle or it is a square. So we would put a different check. Yes, you got it. We'd use basically the nested if statement to check further if it is a square or a rectangle. If the length is 5, then it is a pentagon. If the length is like 6, then it is a hexagon. And if the length is like 10, it is a star. And if the length is none of them, then it is a circle. Okay, so that is fairly simple. So now what we're gonna do is that we're gonna have that if statement here, and in if statement we're just gonna write here len, and in here we're gonna pass that variable approx, and now we're gonna put a double equal sign here to check the length. So let's check it for triangle first. So now what we do is that we write here equals 3, we come to the next line, and now we need to go inside the body of the if, and here we just write cv2 dot put text. Put text is a method that we're going to use to put text on the image. Okay, so when it would identify that, we're just gonna write here first argument image. It is the image on which we are going to write, and then we are just going to write here this text, which is essentially triangle. All right, and here we're gonna have the arguments which it would basically identify automatically, sort of, and we write here x comma y. Okay, and then we write here comma, and we go here, and here we write cv2 dot after that we write here font underscore Hershey, okay, underscore plain. Okay, so there are other fonts as well, font Hershey underscore complex and font Hershey underscore simple. You can use whatever you like. Okay, and then the fourth argument, the fifth one, that would be 0.5, and then after that we just write here a tuple, which would essentially be 0 0 0. That is basically the specification of the color BGR. Okay, so we just want it to be black, so we won't write here any other value other. And now we're gonna put another check, which would essentially be else if, and that check would basically check if the value here of the length approximation, if it is equal to 4, then there would be essentially 2 possibilities, as I've told you. One possibility is that it's a rectangle, and the other possibility is that it is a what? It is, I think it is a square. Yes. So square and rectangle, in both of them, in both of the cases, it could have a value of essentially 4. So we'll check for it further. So we just write here approx here, we put double equals, then we write here 4, and after that we put here a colon. Now inside the body of the if, what we're gonna do is that we're gonna define different sort of, we're gonna identify different sort of parameters of the rectangular, like width, height, and x and y coordinate. So we'll just write here x1 y1, and these are the x and y coordinates, and then we identify width, then we identify height, and we do so we identify this with the help of the built-in method, which is essentially bounding rect. Okay, so make sure that you write the spellings correctly, bounding rect. Alright, so now you have here the parentheses, and inside these parentheses what you're gonna do is that you're gonna pass that variable approx. Okay, so now you come to the next line, and in here you're gonna have an aspect ratio variable here, and this variable would basically have the answer to the width and height division. Okay, so once you divide that, you get that ratio of the width and height for rectangle. You need to make sure that width and height, if they are somehow not same, or if their ratio is like it is differentiating, then it's not a square, it's a rectangle, obviously. So that's why we're gonna need that. So what we can do is that here we can print out this ratio if we want to, or if you don't want to, then you don't print it. Then you can write here aspect ratio, and now you can put a check here that if it is greater than or equal to 0.95, and the other condition, both of them has to be true, and the aspect ratio, that is a variable that we have, if that is less than or equal to 1.05, if both of these conditions are true, then in that case what we want to do is that we want to put that text as a square. Okay, so we just write here cv2 dot put text, and in here we have parentheses, and inside these parentheses we are just gonna pass different variables, different arguments. We write here img, and we write it as square, and then we pass x comma y, which are like coordinates, and then what we're gonna do is that we just simply copy this. Okay, so we copy all of that from here, and we just simply come here and we paste it right here. Okay, so like this. All right, so now what we're gonna do is that we're gonna have an else block here along with an if that condition doesn't work out for some reason, then we have an else block which would say that it is a rectangle. Okay, so what we're gonna do is that we'll just basically copy this from here. Let me just copy all of that, and I come here and under the else block I'm just gonna paste it. And one thing that I want to change, that is the name of it, and I write here rectangle. Okay, so once I do that, now I think we had different shapes. One of them was pentagon or hexagon, I think. So let's do that. So for the next thing that we're gonna write, it is gonna be for hexagon. Okay, so we'll just go here, and here we are just going to write else if again, and here we're gonna write length, the method, and inside of that we'll use the variable approx, and that if that is equal to 5, then it is a pentagon. If that is equal to 6, then it is a hexagon. So we just write here 6, and then we basically come here and we paste the same thing here. Okay, so we paste that, and in here we change it as hexagon. Okay, so now we go ahead and we have another else if statement here. I think now we had identified the hexagon, we have identified the square, rectangle, triangle, and there's one thing left, which is essentially a circle. Okay, so for circle you don't need to actually identify that, you just write here else. Obviously if that shape is none of them, then it's gonna be a circle. So we'll just write here else, and then we write here cv2 dot put text, and inside here we pass img, we write here comma, then we write here the name. In fact, why I'm just writing it, why not just simply paste it what we copied. So we'll just write here circle. Okay, and we are all except one thing, which is I think that is indentation. So make sure that your indentation is correct, because if it is not, it could cause a fatal error. Okay, because Python takes indentation very seriously. So that is the whole code, and I have explained to you along the way as I was doing things. So now let's go ahead, let's save it, and we try to run this code. Okay, so we just go to our terminal and we try to run it. Oh, we've got an extra bracket here. So just make sure that you don't make that mistake. So when I was copying, I copied it like the wrong way, and I had an extra bracket with every cv2.put text. So make sure that you don't make such mistakes. So we save it and we go ahead to our terminal. Let me just clear it. We run our script, and here you can see we have that image actually, but the one thing that we want to do is that we haven't actually showed that image afterwards, right? So the thing is that we have actually showed the image right here, but after performing everything, we also need to show the image after the for loop. So what we would do would we would just simply show that again. So for that, we just write here cv2, then we write here im show, and in here I'm gonna pass the name of the file, which is essentially shapes. It is gonna be actually the window of the file, the name of the window, and then you basically pass the variable. So now if we save it, Control S, we go back to our terminal. And we need to put a comma here. So now if we save it, we are all done. We go back to our terminal and we try to run our script, and there you go, you can see that we have the names of that. We have circle, we have square, hexagon, triangle, triangle, and circle. So I think that we have basically we can basically shorten it, so we can do it like 4, and I think the distance was too much for square. The name was like, you know, it was gone up there. So here you can see that we have square, we have circle, we have triangle, we have triangle, we have hexagon, and we have circle. Okay, so that's it. That's how you basically define and identify these things, these geometric shapes. You can change the font if you want to. You can change that to complex, or maybe some other you know, font that you really like. So that's it. That's how you identify the geometric shapes using OpenCV. So that brings us to our next topic, which is essentially eye detection and face detection. And so the idea is that in order to detect the eyes and the face, what I would do, I would use the HOUR cascade method. Okay, so this is the method that we're going to use in order to identify the face and the eye. So what I'm going to do is that I'm going to open up my front cam and I'm going to identify my face and my eyes using OpenCV. So for that we just need these two files. One is HOUR cascade _i.xml, and the other one is this one, HOUR cascade frontal face default. Okay, so you have to have these two files, and you make sure that you put them in the same directory where your script is, Python script is, because we're gonna use them. In case if it is not in the same directory, you can basically give the straight path to that specific directory where these both files are. So here you can see that we have this one is HOUR Cascade I.xml, so you need to download it. So in order to download it, what you have to do is that you have to go click on raw, and it would take you to another page. And the same thing you need to do with this HOUR Cascade frontal face default file as well. So you click on raw. So now when you click on raw, it would take you to another page. So now here you can see that you're now on this page. So from here you can download this XML file, just right click on it and then click on save page as, and then you can select the directory where you want to store it. I want to store it on my desktop, and I want to store it with the same name, HOUR Cascade _ I.xml. Just save it right here and it would be saved on your desktop. Okay, so the same thing you need to do with this other file as well, which is essentially the HOUR Cascades frontal face default file. So you right click here, you click on save page as. You get to here, you can select the directory where you want to save it, and with the same name I would save it. So I would just save like this. Okay, so once you save these XML files on your desktop, you can basically go right here and you can verify that. And here you can see that on my desktop I have two files. One is essentially HOUR Cascade _ I.xml, and the other one is HOUR Cascade frontal face default.xml. All right, so now I'm just gonna clear it. I'm gonna go back to my script, and here we're gonna code in order to identify my face and eyes. Obviously you can do that with any other video or any other picture as well. It doesn't really make a difference. Okay, so the first thing we need is that we need these two imports, so we'll just keep them like that. So I'm going to remove everything from here. Okay, so I can remove that as well, doesn't really matter. So now what I'm gonna do is that I am going to write code here. Okay, so first thing that I want to write here is that I want to write here the name of that XML file, and I want to read it basically. Okay, so what I would do, I would just write here the name of the variable, let's call it face, and then we write here equals to, or we can call it face _ file. Okay, so we read it. We do that by using right here cv2 dot cascade classifier. Okay, make sure that you write the spellings right, CASCADE. Then you write here classifier, CLASSIFIR. I'm just making sure because if you have a spell mistake, it would cause a syntax error. So now here you want to write that file name, which is essentially, first of all, you can write here the frontal face file, which is HOUR Cascade, and then you write here underscore, then you write here frontal face _ default, and then you write here .xml. Okay, so now you have that, and now you come to the next line, and in the same way you acknowledge the other file, which is essentially I file. Okay, so you just write here I file, and then you write here equal sign, and then you write here cv2 dot cascade, then you write here classifier. Okay, and then you have brackets here, and inside this bracket you're gonna write the name of the I file, which was essentially HAUR, and then you have here cascade _ I.xml. Okay, so I hope you have got the point. So that was the thing for this thing. So now you're gonna go ahead and you're going to read basically your video device, whatever it is, your webcam basically. So in order to get that, all you have to do is that you have to write here a variable. Essentially you write here cam, and then you write here cv2, then you write here dot, and then you write here video capture, and here as an index you pass 0. You can pass here -1 as well, and if you have more than one cameras, then you can essentially write here 0, For the second camera, for the first camera you would write 0, for the second camera you can write 1, 2 for third camera, 3 for fourth camera, and so on and so forth. Okay, so I'm gonna use my default webcam, so I'll just write here 0, and after that I'm gonna have here a while loop essentially, which would be an infinite while loop. So for that we just write here while 1, and then basically I'm gonna have a return value, so I just write here underscore. You can also write RET, it doesn't really make a difference. Then I write here IMG, which is essentially a variable name, and I would try to read my basically I would try to read my cam or my webcam. Okay, so once I read that, now I'm gonna turn it to gray, so I'll just write here IMG, which essentially capital G represents gray. Okay, and then I'm just gonna write here CV2 dot CVT color, and then essentially I'm gonna pass here 2 arguments as we always do. One is gonna be IMG and the other one is gonna be CV2 dot color underscore BGR 2, and then we write here gray. Okay, so now this was the second thing, and after that we are going to write here face variable, let's say. So in here we're going to use that face file that we have basically created a variable of. So we just write here face underscore file, and now we write here dot. We use a built-in method called as detect multi scale here. Okay, and in here we pass the variable imgg where we have the grayscale, and then we're gonna write here 1.3, let's say. Then we write here the font. And then we write here 5. All right, so now once we do that, after that we go right ahead and we basically create a for loop. So in this for loop we're gonna have 4 things, x and y coordinates, and we're gonna have width, and we're gonna have height. Okay, so these are the 4 things that we're gonna have, and then we're gonna have here in face. Okay, so now we're gonna go inside the body of the for loop and make sure that you take care of the indentation. So obviously when we identify the face, we want to put a rectangle right around the face. So for that, what we would do, we just write here cv2 dot rectangle, and then we're gonna write here img, we put a comma here, and then we're gonna have here x and y, which are the coordinates. Then we basically go here and we adjust them according to the width and height. So we just write here x plus w, and we adjust the y one with the height. Okay, so y plus h we just write here. Okay, so I hope you've got the point. So now what I'm gonna do is that I'm gonna write a comma here, and then we basically define the color here, which is gonna be blue 255 0, 0. Okay, so you can change it by changing the color code here. So I would like to keep it blue, and then we write here the depth of it, and that is going to be essentially 2. So the next thing that we want to do here is that we're going to write here the image. We're going to basically use that image that we have scanned. So now we are going to use ROI, and we're going to write here ROI imgg, and then we write here equal sign. Basically this is nothing, just a variable name, so it is not doing anything here. And then we write here imgg, and now we basically work with different parameters here. So first we work with the y coordinates, and we write here y plus h. Okay, and then we put a comma here, and now we write here x plus w. Okay, and the same thing we're gonna do with the other one, with the colored image. Okay, so that one was with the gray image. So for that we just write here this thing here, and we remove this one from here, and we remove this capital G here. Okay, so now what we're gonna do is that, keeping ourselves inside the for loop, we're gonna define here another variable for face, okay, for eyes, excuse me. First thing we have done it for face, and then here we write eyes, and after that we just write here equal sign, and then we write here I underscore file, which is a for I cascade file. Okay, so we write here that, and then we just write here you know, we write here dot detect multi-scale that we have done previously, and then we're just gonna write here ROI underscore IMG. Okay, so that's what we're gonna do here. So the next thing that we're gonna do is that we're gonna use a for loop on that as well, and we're gonna do the same thing essentially. So we just go here, and we have here X comma Y comma W comma H, and actually we need to differentiate them because we are already using these variables for X and Y coordinates and for width and height as well. So we're gonna call it XI coordinate and YI coordinate. We're gonna call it WI coordinate, width I coordinate, and height I coordinate. Okay, so we specify them, and then we go ahead and we use the eyes. Okay, so now we need to take care of the indentation of another for loop which is inside the for loop. So we just go right here, we have here CV2 dot rectangle, and in here we're gonna pass arguments. The first one is gonna be RIIMG, okay, and the other one is gonna be EX comma XE comma YE, okay, which is essentially the coordinates here that we have mentioned. Then the third argument, in the third argument actually we're gonna do the same thing as we have done above. So for that we just write here XE plus W, okay, and then we write here comma WE actually, and then we write here comma, and then we write here YE plus. So once you write that, now you're gonna put a comma here, and now you're gonna select the color of it. So let's select this one, blue, and we just go right ahead. So now we put a comma here and we write 2. All right, so now we are gonna come out of these for loops, and we're gonna just write here CV2 dot IMShow, and then we write here the window name, which could be anything. Let's call it image or video, whatever you want to call it, and then you write here comma, and then you write here IMG, the variable name which we are reading essentially. And now once we have done that, after you know, reading it, we want it to basically go right ahead, and when we press one specific key we want it to delete, right? So what we're gonna do is that we're gonna write here if, and after that we write here CV2 dot wait key, okay. So you want the operation to be cancelled on pressing a specific key, okay. So we just write here, you know, 30, and then we write here and then we write here 0xFF, okay, or I think it's gonna be it's gonna be 0, okay. So this is related to the hardware. So 0xFF, and then we write here double equals, we write here 27, and if once that happens we want the program to break, okay. So we write here break, and then finally what we want is that we want to destroy all the windows, and we want the cam to release all the resources. So for that we just write here cam dot release, and we have all the windows as well. We have all the windows delete here, okay. So now we are all done. We have downloaded those 2 XML files, and after that we have performed a brilliant function of reading the face and eye. Okay. And one thing that you need to do is that you need to write here a colon here and make sure that these 2 things are aligned. Check on the indentation once. So now if we go ahead and we try to run our program, if I hit enter, here you can see that it is able to detect my eyes and my face as well. Okay, hope you've liked it. Let's move on to our next topic, which is topic number 16, and that is Matplot library. Okay, so Matplot library is a plotting library for the Python programming language, and it's numerical mathematic extension, which is essentially NumPy. Okay. It provides an object-oriented API for embedding plots into application using general-purpose GUI toolkits like, WX Python, Qt, or GTK+. There is also a procedural PyLab interface based on a state machine like OpenGL. And it was designed to closely resemble that of Matplot library is a Python 2D plotting library which produces publication quality figures in a variety of hard copy formats and interactive environments across platforms. Matplot library can be used in Python scripts, the Python and IPython shells, the Jupyter Notebook, web application servers, and 4 graphical user interface toolkits. Matplot library tries to make easy things easy and hard things possible. You can generate plots, histograms, power spectra bar charts, error charts, scatter plots, etc. with just a few lines of. For simple plotting, the pyplot that we're going to use as well module, it provides a MATLAB-like interface, particularly when combined with IPython. Okay. So for the power user, you have full control of line styles, font properties, access properties, and things like that, which are related to plotting. Okay, so now let's go ahead and let's try to install that. So there are basically 2 fundamental ways in which you can install. Either you write here pip install matplot library, but it is a discouraged way, so it is better if you install it in this way on Linux. Okay, so for that you can write this command sudo apt get install Python matplot library. Okay, so when you will hit enter, it would ask you for the password if you're hitting enter for the first time with sudo. So here you can see that I have already installed it, so it has not taken much time, but when you'll be installing it for the first time, it would take quite a while downloading it and then basically extracting it and installing it. Okay, so how do you know that if you have successfully installed the Python matplot library? So the idea is that you just simply write here Python, you go to Python interpreter, and here you can write from matplot library import pyplot as pt. Okay, so when you hit enter, if you do not get any error, it means that matplot library is installed successfully. If in case you get any sort of error, it means that matplot library was not installed. Okay, so you can come out of Python, and now what we can do is that we can write a simple script in which we basically use this script, use this matplot library in this script to open up an image in a plotting way. So on which you can basically sketch different sort of plots. So the image that we're going to use, let's go ahead and let's see that which image we are going to use here. So let's say that if we use this geo.jpg, so now in here we're going to write our code here. So we need CV2, NumPy we don't need it as of now, but let's keep it that way. We go here, we write here the same line that we have written to check the matplot. So we just write here from matplot Matplot library import py plot as pt. Okay, so we import that, and after that we are going to specify the image that we have here. So that image is gonna be, we basically are going to read it, so we read it in here img equals, then we write here cv2 dot imread, and now inside this we are gonna write a method. So basically we write here the name of the file, which is essentially geo.jpg. okay, so now we go to the next line. Here on this next line, what we're gonna do is that we are going to write here we're going to show that image basically. So simply we write here im show, and we write here a window. On window name we write here img, we put a comma here, and after putting a comma here we can write here the variable name, which is essentially img as well. So now we have that image, so, and we have shown it as well. So now we are going to convert that into gray. Okay, so for that what we would do, we'll just write here img equals, and then we write here, after showing it, obviously we can use the same variable. If we would have used it before, then we would have used another name of the variable, because in that case we had to show the original image later. So that's why now first we have shown it, after that we can use the same variable name. It doesn't really make any difference. So here we write here cv2, then we write here dot, and then we're gonna write here cvt color. Okay, then we're gonna write here brackets, and after that we're gonna write here the variable name, which is essentially img, and then we write here comma, then we write here cv2 dot, then we write here color underscore bgr2, and then we write here RGB. Okay, so now we come to our next line, and in here we're gonna write here the PT. Okay, so we write here PT, and then we write here dot, and then we write here im show, and then we write here img. Okay, so after that we just go ahead, we write here pt, then we write here dot, and after that we can have ticks here, so we just write here x ticks, and we have brackets in here, and we have square brackets as well, and after that we put a comma here, and then we do that for y-axis, and then we write here pt dot y-text, we have brackets, and inside those brackets we have empty square brackets. So once we have done that, now we can write here pt dot show, and now it would basically plot a graph sort of y-axis and x-axis on the screen, on the image. Okay, it would not actually draw something, it would just draw the axis of y and x on the image. Okay, so finally we are done. So just write here cv2 dot then you write here wait key. Okay, so any key you press, it would go it would basically stop running the program or close the windows. Okay, so now we save it, we go back to our terminal, and we try to run our script. So we hit enter, and there you can see that this is our figure 1. So basically it is not showing the genuine image here, but if you see here it is showing right here. So what we can do is that here you can see that on this window you have different options because of Matplot library. Okay, so generally when you use only im show, you don't have these options. So here you can reset the original view, or you can go back to the previous view, you can forward to next view, you can pan axis and start moving it around. Here you can see that these are the options and the things that you're performing using Matplot library. If you click on this, it would come here, configure plots. Okay, you can definitely set different sort of values, and as you set values you can see that it is moving, the picture, the image actually moves towards the bottom or towards left, right, and top as well. Okay, so you can also reset that as well. Okay, so if you drag it, if you want to drag the image somewhere, you just have to select different options and it would start doing it. Okay, so that's how you use Matplot library, that's how you install it. So that's it from this course. There are two topics left, which is blurring and smoothing of the images using OpenCV, and then we have the road lane line detection. This is the 18th topic. So what I'm going to do is that I'm going to skip both of them and I'm going to compensate these two topics, especially the one which is related to the road lane line detection. I'm going to create one separate video on this topic, and in future, if we create another course on OpenCV, we'll definitely include this blurring and smoothing of the images. Okay, so we have a time constraint, so this video wasn't supposed to be longer than 3 hours. So I promise you that I'm going to put this 18th video, which is road lane line detection, as a separate video as well. Okay, so I hope you have liked this course, you have enjoyed it, you have learned something new. For written articles, you can always visit our website linuxin.com, and for further videos, for free content, free courses, new videos on technology, subscribe to our channel, YouTube channel, and give this video a thumbs up if you really liked it. If you have any questions, ask them in the comments below. Thank you so much for watching, and I'll see you in the next video.